Hello. On this video, I hope to show you how to find the probability and the population of the population mean, population standard deviation, and population variance on a hypergeometric probability distribution. And if you're given the formula, how to do that on a TI-89 platinum. An example of a hypergeometric probability distribution would be this. For example, a bowl has 10 white beans, 16 black beans, and you put all those in a bowl, you mix them all up, and randomly you select 7 beans without replacing them. Find the probability that exactly 4 beans are chosen or are white. So what you have, and I have it here, but I'm just going to rewrite it. You have 26 beans. You're going to pick, there's 10 beans that are white, and that would leave 16 beans that are black. You pick 7 beans, and then you randomly select, and you want to know what's the probability you'll have 4 white beans and 3 black beans. So if you have these 7 beans in your hand and exactly 4 are white, that means the rest must be black. Now we use a certain, so let me just first start this way. To do the probability, it is a combination. So there's not important what the order is you choose those 4 white beans because they're all white. There's no distinction between them. So the probability, either P of X or F of X, would be 10 choose 4, which is 10 combination 4 times 16 combination 3 over 26 combination 7. Or it's also written as 10C4 times 16C3 over 26C7. So let's do that. Let's turn on our calculator. We're going to go home. We're going to go ahead and clear this. And now how do I do 10 choose 4? Well, first thing you do is you have to get to the math key, and to do that, because it's above the number 5, it's second math. Then you choose 7 because 7 says probability. So I'm choosing 7 for probability. Now to do an NCR, that's the number 3. So I'll choose the number 3. And it says NCR with open parentheses. The first number is 10, comma, above the number 9 is a comma, and then 4, close parentheses, times. Now we'll go through the process again. Hit second math. The number 7 is probability, and the number 3 is NCR. And it would be 16, comma, 3, close parentheses. Excuse me. Sorry. Divided by, and we'll do the same process. Second math, and it will be number 7 for probability, number 3 for NCR. And you do 26, comma, 7, close parentheses, equals, and you've got this exact number. If you see, that's an exact number. So what happens when you come up with an exact number? If you notice here, above enter, there's entry, and there's also this little thing that says approximation. Do you see the color is in like a fluorescent green, chartreuse kind of? So maybe yellow, some people would call it. So we're going to use this color, this little diamond. You press this diamond and this again, and it gives you 0.178778. And that's what it should be. So that's what we got. So again, it was this diamond and here, and it gives you the approximation versus the exact value. So in our case, it gave us the exact value. I wanted it as approximation, so I went ahead and asked to do diamond in here. Now, the population mean, let me go talk. There's a couple things I need to show you. 26, we're going to call this M. 7, we're going to call N, which is the sample size. 16, we're going to call B for the black. And W for we want, or the white. So let me just go, oops, I don't like the way I wrote that. Put that as W. 10 is W. So I'm going to highlight the M, the B, the W, and the N. We'll need those four values when we'll only need three of them when we talk about the population mean. Population mean is N times W over M. 7 times 10 over 26, excuse me. So I'll clear it, and I would do 7 times 10 divided by 26 equals, and it gave me an exact value. The hit it, 35/13. Again, we want an approximation, so hit the star key and enter, and that would be 2.69231. 2.69231. Next, we want to do the population variance. So that's the population mean. To do the population variance, that's the formula. So in this case, the variance, and it's probably hard to see that, so let me just write that formula. Sigma squared is the population variance. It's N times W over M times B over M times M minus N over M minus 1. So this is the same as what we started with here. 7 times 10 over 26. B is 16, so that would be 16 over 26. And M minus N, 26 minus 7 gives me the 19, and 26 minus 1 gives me 25. So 7 times 10 is 70 over 26, times 16 over 26, times 19 over 25. So to do this on our calculator, I'm just going to go ahead and clear everything first. I would go ahead and go 70 times 16 times 19 divided by, open parentheses, 26 times 26 times 25, close parentheses. It gave me an exact value. I want approximation, so hit my star key and then hit the diamond key and hit enter, and it'll give me an approximation. 1.25917, got it right there. Now, what happens if you want to find the standard deviation? That's what I have right here. So I'll try to keep everything I can in here. I think that's pretty much as good as I can get. So here, do you see this 1.25917? That's the square root of that number right here. So I can hit the square root of this, and how do I hit the square root of that number that I have in there? Well, I would hit second, and square root is above the times key, square root. And the answer is above the minus button. So look above the negative button, and it says ANS. So second, ANS. And it should enter. Oh, I didn't like something. What did I miss? I missed a parentheses. There we go. Okay, so let's try this again. Hit another parenthesis. So let's go ahead and escape that thing. Hit another parentheses. Enter. And so it's going to take the square root of that big number as 1.1221. Sorry about that. So I missed a parenthesis. It told me I missed a parentheses, and then I put another parenthesis there, and now I'm good. Now, what if you just wanted to get this value, square root of this, without going through the population variance? In other words, I'm just going to put the whole thing in my calculator so that when I'm done, I will have this value. Well, I'm going to clear it, and it's the square root. Second above the x is the square root. There's a parenthesis already there. I hit 70 times 16 times 19 divided by another open parentheses, 26 times 26 times 25. I'll close a parentheses that close the denominator. I need one more closed parentheses. So I have to close the parentheses twice before I hit the equals. And it gives me this 2 square root of thing. And I said, oh, I just want to know a decimal approximation. Hit the diamond key, hit this enter key, and there's go 1.12213, which is what we have right here. Well, I hope that this helped you. I hope that this is beneficial. Thank you so much. Thank you so much for watching. I hope that you have a blessed day. And thank you and bye. Bye-bye.